Right, so, hold on. Okay, so this is a question where you're trying to find the maximum vertical distance between the two curves. Yeah? When you're doing these sort of questions, optimization questions, the first thing you have to ask yourself is, what am I trying to maximize? What is it here that I'm trying to maximize? Exactly, vertical distance. So what I need to do is I need to set up an expression where I've got vertical distance is something. Because after I've done that, what I'll be able to do is I'll be able to differentiate my vertical distance. Okay. So how do I find my vertical distance? What is an expression for my vertical distance? In other words, what's the difference from there to there, and difference from there to there, and there to there, etc. How do you find those lines? Yeah, it's the red curve. It's the red curve minus the blue curve. Happy with that? That makes sense? So the red curve, 2 minus x squared, minus the blue curve, which is this. Okay. So now we've got a function that will explain my vertical distance. I'll be able to differentiate that. Before I differentiate, let's make it a bit tidier. So it's going to be 2 minus x squared minus x squared plus 2x plus 10. Look at that. So that's going to basically be negative 2x squared plus 2x plus 12. Have that function? Okay, so now I'm trying to maximize that. So I'm going to go dv over dx. That's going to be negative 4x plus 2. Happy with that? So now I'm trying to maximize something. What do I do after I've differentiated it? Yeah, I've got to make that equal 0. So dv over dx equals 0 at a maximum. So negative 4x plus 2 equals 0. So therefore 2 equals 4x. So therefore x equals, that's a funky looking 2, that's a half. X equals a half. Happy with that? So what we're saying there is that on this graph, when x is a half, this is the maximum vertical distance just there and there. Okay. Now, you could differentiate this a second time. If I differentiate that a second time, because that is less than 0, it is concave down, therefore it is a maximum. That's just me proving that it is a maximum, because it could be a minimum or it could be a maximum. You will have to prove them eventually. Okay. But so what's the maximum vertical distance is the question. So the maximum vertical distance is just negative 2x squared plus 2x plus 12 when x equals a half. So you just chucked it into your calculator. 2 lots of a half plus 12. That's a quarter times 2, that's a negative a half. That's just going to be 12 and a half. So that is the maximum vertical distance. Okay. One thing that wasn't said in the question up here, but was said in the book, said it has to be between your two intercepts. Okay. Well, that's that question there. Does that make sense? Key thing was what are you trying to maximize or minimize? So with the next questions you're going to do, ask yourself that question. What is it you're trying to maximize or minimize? Even these guys here are asking themselves that question. question he asked this morning. What is it you're trying to maximize or minimize? Set that function up first, then differentiate it, then do it to button bar and make it equal 0. Yep. Cool.